Alright, you guys, here is Mechanical Advantage YouTube lesson. Okay, so we're attaching a worksheet for you guys to do. Like I said, you can type them in there. I want you to type in the equations as well, and then show your work, and then just circle the answers with MA. I'll show you how that looks. These are just some examples on how to do each one of them, and so I'm just going to go through each one. There's the lever, the pulley, the wheel and axle, the incline plane, and the wedge. We're not going to worry about the screw for these calculations, but you'll have at least one example of each one of these to do on your sheet. So we'll just start with one at a time. Okay, we'll start with the lever. If we take a look at the question here, how do you calculate the mechanical advantage? It's length of the effort arm divided by length of the resistance arm. Okay. And so if you look here, right about here, you see that the effort arm is 90 centimeters of this crowbar, okay? The fulcrum is actually the curve on the crowbar, and so your effort arm is actually 10 centimeters. We're gonna try to get a nail out or whatever, okay? So let's show how do we do this work, okay? So it's really simple. We're just gonna follow this equation, the length of the effort arm divided by the length of the resistance arm. So we'll go 90 centimeters, which is the effort arm, divided by 10 centimeters, which is the resistance arm. Okay, so that's going to give us 9, right? So we just short work there. And so how do we write that? We just go 9, and then we can just do capital M, capital A, circle it. So 9 is the mechanical advantage for that lever. Got it? Okay. All right, these pulleys are a little bit weird. They're a little bit different, okay? You're counting the segments, all right? And so the segments are just the string, basically. And so just remember, gentle reminder here, do not count the segment that you're pulling on, okay? So I tried to put an arrow on that segment that you're pulling on. So for example, this one would just be a 1, okay? You're pulling here, so you don't count that one, you only count the one that the load is on. The L stands for load, okay? Here's a 2, it's fixed up here. There's a movable pulley, that's where you get your mechanical advantage, is the movable one, so the load is on it. And then this one's changing the force, so we have 1, we have 2 strands. Remember, we don't count the one we're pulling on, okay? And here's a mechanical advantage of 3. This is the example for it. And so if you look here, we're pulling up on this one, okay? It's looping around, that's 1. It's looping down, that's 2. And then it's attached to the bottom of the fixed pulley on the top for 3. So we have 1 segment, 2 segments, 3 segments. So this would be a mechanical advantage of 3. That would help quite a bit with lifting up the loads. You don't usually see these. What they would usually do is they'd usually loop that around to get a mechanical advantage of 4 coming down, because then you're actually pulling down, which is easier than pulling up. But this mechanical advantage of 3 would still be pretty helpful. Okay, so that's just an example. So when you just look at your picture, just count the strands. Do not count the one that's being pulled on. Okay, wheel and axle. Here's the example of wheel and axle. It's the wheel radius divided by the axle radius to find your mechanical advantage. So this is a submarine hatch. We're just pretending, obviously. And so we have to turn that thing, turn it. What is our mechanical advantage of that wheel and the tiny little axle that goes to undo the latch on the hatch? Okay, so we have 25 centimeters is the diameter, or our radius, sorry. And so we have our radius of 25 centimeters, okay? And then we have our 5 centimeter axle, okay? And so cross that out, goes in how many times? 5. So our mechanical advantage for this one is gonna be 5, capital M, capital A, 5, okay? So that's what it looks like for the wheel and the axle, okay? Then our incline plane, this one's pretty simple as well. We just take the length of the slope divided by the height of the ramp, okay? So on this one, you can see the length of the slope is 8 meters, sorry. The height is 2 meters, so a little over 6 feet high to get to that door there. And so we're just trying to get into a door. It's on the second level, but we have to be easy. We have to make our work easier, right? So what is our mechanical advantage for this one? So we're just going to take the length of the slope, okay, which is 8 meters. We're going to divide it by the height, which is 2. Pretty simple math on that one, right? Okay, and so our mechanical advantage for MA for this one, okay? And so there it is there, the incline plane, length of slope divided by height of the ramp. 8 divided by 2 equals 4, okay? And our last one is a wedge. Let's say we got an axe. We're trying to chop this log. And on this one, we take the length of the wedge divided by the width of the wedge, okay? And so on this particular one, we have the length of the wedge, which is 9 centimeters. It's a pretty small axe. Divided by 3 centimeters for the width, okay? And we're going to get a mechanical advantage of 3, right? And so 3 MA, and that's what that looks like. The wedge, length of the wedge divided by the width of the wedge. And there is your science math lesson for today. Calculate a mechanical advantage of all these simple machines minus the screw, okay? And so just good luck. If you have any questions, you can email Mr. Robinson or I. And man, I hope you guys are doing well. It's a beautiful day. We did the outside lesson again. And so there it is all for you. Turn it sideways. I don't know how that's going to work. Maybe I'll just back up. All right. So made that new outdoor chalkboard for you. We went old school, you guys. See you. Once again, I hope you're doing good. My son's helping me out. He's using a lever today, raking some leaves. So simple machines all around the place.